Refraction of light. Refraction of light. Light as a plane surface. Plane surface. Plane in the chapter. So once again, I'm going to recall all points. All points. So up to what I explained topics, explain introduction. In this class, I explained refraction of light. Refraction of light. So what is the meaning of refraction of light? What is the meaning of, what is the definition of refraction of light? Refraction of light means light which bends from actual path on entering into the another medium is called as refraction of light. Refraction of light. Next, incident ray. Incident ray means beam of light is traveling on another medium is called as incident ray. Next, point of incident. Point of incident means incident ray strikes on point interface of the two surface is called as incident point of incident ray. Point of incident. Next, angle of incident. Angle of incident means angle between incident ray and normal is called as angle of incident ray. Next, another definition we have also, angle makes with the angle which incident ray makes with normal is called as angle of incident. Angle of incident. One of the parts of the uh, one part of the light ray gets reflected back into the same medium is called as reflection. Reflection ray. Reflection ray. Angle next to angle of reflection. Angle of reflection means angle between normal and reflection ray is called as angle of reflection. Angle of reflection. Next, another part of the light ray. Another part of the light ray is travel. Another part of the light ray is travel from one medium to another medium. So that is refractor ray. Refractor ray. Refractor ray means light which bends from actual path on entering into the other medium is called as refractor ray. Next, angle of refractor ray. Angle between normal and refractor ray is called as angle of refractor ray. Angle of refractor ray means angle which refractor ray makes with normal is called as angle of refractor ray. Angle of refractor ray. Next, angle of deviation. Angle between normal and actual. Sorry, angle of deviation. Angle of deviation means angle between actual direction of incident ray and refractor ray is called as angle of deviation. Angle of deviation. Angle of deviation. Now, next one is emergent ray. Emergent ray means light which emerges out from another medium is called as emergent ray. Next, angle of emergent means angle between normal and the emergent ray is called as angle of emergent ray. Another definition we have also, angle which emergent ray makes with normal is called as angle of emergent ray. Angle of emergent ray. This is all basic points. All basic points. And once again, so we have a law of refraction. We have the two laws, incident ray, normal, refractor, always lay in a same plane. That is a law of reflection, number one. Next, law of reflection, second law is Snell's law. Snell's law means product of refractive index of the material and sine of angle of incident at all points in the medium is equal to 0. That is Snell's law. That is a Snell's law. That is a law number 2. Law number 2. This is a very, very important. That is a very, very important. Next, so reason. Refraction due to change in speed of light. Light travels from one medium to another medium. Refraction due to change in speed of the light travels from one medium to another medium. That is refraction. Refraction cause. Next, in case of refraction, frequency and phase do not change. Only speed and wavelength will be changes. Will change. Both are changes in a light. In a light, when light travels from one medium to another medium, means wavelength and speed of light both will be changes. Both will be changes. Frequency and phase do not change. Do not change. Colors of light is determined by the frequency, not by a wavelength. Not by a wavelength. Now, this is a point very important. Next, so refractive index. Refractive index means refractive index. Refractive index gives idea as how fast, how slow light in a medium. This is a gives idea. Refractive index gives idea as how fast, how slow light travels in a medium. Light travels in a medium. It gives that's information. That information. Next, absolute refractive index. Absolute refractive index means letter is n or mu, and it's equal speed of light in a vacuum by speed of light in a medium. This is and indicates absolute refractive index is equal speed of light in a speed of light in a vacuum by speed of light in a medium. Absolute refractive index is defined as the ratio of speed of light in a vacuum to speed of light in a medium. It has no units. It has no dimensions. No dimensions. So we have that one. And next, next one is relative refractive index. Relative refractive index. Relative refractive index means we have the one relation. The relation is n2 1 is equal to n2 by n1 is equal to. So n2 1 is equal to n2 by n1 is equal to b1 by b2 is equal to lambda 1 by lambda 2. That is meaning is refractive index of medium 2 related to medium 1. N2 by n1 is equal to b1 by b2 is equal to lambda 1 by lambda 2. So refract light travels from first medium to second medium. Light travels from first medium to second medium, but refractive index is medium 2 with respect to medium 1. Next, refractive index of first medium with respect to second medium means n1 by n2 is equal to b2 by b1 lambda 2 by lambda 1. That is refractive index of first medium with respect to second medium is equal to light travels from second medium to first medium. Light travels from second medium to first medium. First medium. So we know some materials having refractive index is different. The list is air. Air refractive index is 1.003. 1.0003, and diamond has a refractive index is 2.42. 2.42. Highest refractive index is diamond has highest refractive index that is 2.42. 2.42. The refractive index. Now we know some material having corrosion and water. So water refractive index is 4 by 3rd, and glass refractive index is 3 by 2. 3 by 2 glass. Now corrosion and corrosion has highest refractive index compared to the water refractive index. But in mass density, water has mass density is higher than to the corrosion. Than to the corrosion. Now that is what we discussed in the previous class. Now total internal reflection also we discussed in the last class. Total internal reflection means light should travel from denser medium to rarer medium. In first case, angle of I less than angle of R refractory in the denser medium. Angle of I is equal to critical angle. Refractory is travel along the interface line. Next, angle of I greater than 2. Critical angle means refractory light travels from denser medium to, again it will be reflected denser medium at the point of incident. Angle of I greater than 2 critical angle means total internal reflection takes place at the point of incident or at the interface. That is total internal reflection. Application of total internal reflection means mirages and optical fiber, diamonds, This is the application of total internal reflection. Total internal reflection. Next, I explain lab activity one. Lab activity one. So to show the I show the relation between angle of phi and the angle of r and sine of angle I by sine of r is equal to constant. I show that relation also. Next, I'm going to explain lab activity 2. Lab activity 2. In lab activity 2, what I'm going to explain in the lab activity, you see that lab activity 2, understand the lateral shift. Understanding the lateral shift. Lateral shift. Understanding the lateral shift by using glass lab. Glass lab. Lab activity 2. Lab activity 2. In the lab activity 2, lab activity. So lab activity 2 means understanding the understanding understanding the lateral shift. Lateral shift. Lateral shift by using glass glass slab. Glass. So this is a lab activity 2. Understanding the lateral shift by using glass slab. Glass slab. Now, so we need, so what we need, suppose I'm doing to the practical way. I'm explaining in practical way. I'm explaining in practical. Now, you see, so I need the material. This is A, this is A. What we have to do is, this is A. What we have to prove, understanding the lateral shift by using glass. So what is the meaning of lateral shift? First we have to know. Okay, now you will see I need material. Material. I require material. I require material. So what I required material, I need board, drawing board. I need one drawing board. Next, drawing board means you take this board. This is better. Drawing board. I need a white chart. I need pins. I need a protector. I need pencil, eraser, and as a clamps. I need this is all things. This is a material. Material. This is a material. So what I need material. So I need material and drawing board and white chart. White chart. Next, clamps and pins, scale, protector, pencil, eraser. This all pins also. Pins also. I need this all things. This I need all things. Next processor. Next processor. So what is a processor? Processor. This is a you feel this is a board. Drawing board. You feel drawing board taken as a drawing board. Now next, I'm taking to the white chart. White chart. Next, I'm taking to the white chart. That white chart keeps on the board. Keeps on the board. White chart keeps on the board. In so you take the clamps. Clamps attach to the board and paper. So clamps pin the board and white chart. Board and white chart. Boarded white chart. The paper is now is a type. Paper is tied by the pins. Tied by the pins. Now next I'm taking the one glass slab. Now I'm taking the glass slab. That glass slab is placed on middle of the paper. Glass slab is placed on the middle of the glass slab. So glass slab is placing it. Glass slab places middle of the paper. Middle of the paper. Now we'll see middle of the paper. Middle of the This is a glass slab. Glass. So what is the shape of the glass slab? It is a rectangular shape. So glass slab kept on middle of the paper, and this corner, this is A point, this is a corner B point, this is a C point, this is a B point. B point. Now, so this is a glass slab is placed on the paper. So we have to draw the lines. We have to draw the lines in the outlines. Outlines. This is outlines of the glass slab. I'm drawing this is the outlines of the glass slab. Glass slab. Now I'm removing. Now next I'm removing the glass slab. Next, so we remove the glass slab from this middle of the paper. Middle of the paper. So we are seeing that this is the outlines of the rectangular glass slab. This is the outlines of glass slab. This is a A point, B point, C point, and D point. Now next, I'm taking the protector. Now this is a protector. Now this is a protector. Now this is a protector. Now this is angle 10 and 30, 40, 50, 60, 70, 80, 90. Now this is a 20, 30, 40, 50, 60, 70, 80, 90, like this. This is line, this is a AB line, this is AB line. This is a line, this is a protector line, this line. And the protector line should coincide to the AB line. AB line, this is a AB line. This is a line of protector. This is a AB line. This is a protector line. Line coincide to the AB line. Coincide to the AB line. This is a point. This is a O point. Now this is a this you take the pencil and so you put the dot here. Put the dot here. Now next you want to remove this protector. Now so remove the protector. Remove the protector. Remove the protector. And we have the dotted lines. This is a two dotted lines we have the. So we put the two dotted lines. Now next you take the what you take the scale and so place the scale here. Draw the straight line. Straight line joins the two dotted lines. Straight line joins points. 2 points because this is a normal line. Normal line. This is a straight line. This straight line is this is a straight line. This straight line is perpendicular to the AB line. This is a straight line. Straight line drawn perpendicular to the AB line. This is we call normal line. Normal line. Now next again protector should be placed on AB line. Protector as again place AB line. Place AB line. Now this is a 10 degrees. 10, 20, 30, 40, 50, 60, 70, 80, 90. Now you take the pencil. Now you take a pencil. Now you take a pencil. This is a 10 degrees. This is a 20. This is a 30. And so you put the dot at this place. The dot is at this place. Now, so we remove the protector one second. We remove the protector. Now we remove the protector. Now we remove the protector. Now, so you take the scale and pencil. Scale and pencil. Again, you should take the scale and pencil. Now we take the scale and pencil. Now we take the scale and pencil. Now, so here the pattern keeps like this, and so we should draw this line. Draw this line. We draw this line. This is a what is the meaning of this one? Because this is a beam of light. So this is a beam of light. Beam of light. Beam of light is traveling. This is a beam of light is traveling towards this another. This is a glass slab. Glass slab. Glass slab thickness. Tensor medium. Tensor medium. Tensor. Now here, A is well. A is the thickness. Radar medium. Radar medium. This is a radar medium. Now this is we call instant ray. Instant. This is beam of light is traveling towards another medium. Another medium we call instant. Instant ray. This is angle of 50. Angle of is equal to 30 degrees. Right. Now, with the actions, this is the actual direction of incident. Actual direction of incident. With the actions beside. This is the actual direction of incident. When glass these options means this ray goes high. This ray goes straight. This ray goes straight. Here there is no glass slab. This ray goes straight. This is goes straight. Goes straight. Now, next I'm taking glass slab. Glass slab is placed here. And next, I'm taking the glass slab. Glass slab is placed here. What we have the next? So glass slab is placed here. Glass slab is placed here is what we have had. This is the instant ray. This is the instant ray. Glass slab is placed here. Glass slab placing here. Next, I'm taking. Two pins. Two pins. Two pins. The pin is I'm taking the two pins. This is a pin. This is a pin number one. This is a pin number. This is a pin number one. Pin number one. This is a pin number two. So pin is a pin. This is a pin is and stick here. Pin is inserted at this point on this line. So pin one more pin is inserted on this line. On this line, this is a pin number. This is A, B, C, D. This is a PQ pin. PQ. This is a pin number one. Pin number one P is inserted on this line. This is the second pin. Second pin is also inserted in this line. Both pins are in a straight line. Both pins are in a straight line. Now glass slab is inserted here. Now glass slab is present here. Now the glass slab is placed. Glass slab is placed on ABCD line. ABCD. Placed on the board. Placed on the board. Placed on the glass slab is placed on board. Now glass slab is at this place. At this place, now my eye is keep here. My eye is keep here. My eye is eye keeps here. I'm seeing to the my eye is keep here. My eye is seeing to these two pins. It is like suppose my eye is keeping here. I'm taking to the two lines. I'm taking the two pins. One more pins. I need one more two pins. P, Q, R, S pins. R, S pins I'm taking. Now, so what we have to do means simply I'm seeing my eye keep here. My eye keep here. I'm seeing to the two pins through the glass slab. What I'm doing here means what I'm doing here. Simply my eye keeps here. My eye. I am seeing two pins. I'm seeing P Q pins. I'm seeing P Q. I'm seeing P Q pins through glass slab. Through glass slab. Now I'm seeing to the P2 pins in a circle, through the glass. Next, I'm taking the RS pins. RS pins also I'm keeping here. I'm keeping. So this is a pin number. This is R pin. I'm keeping. This is R. This is one more pin. This is a RS pin. RS pin. This is a one more pin. one more pin. This is pin number. This is R. This is R. This is S. Two pins stick on the board. Stick on the. Now I'm seeing the R S P Q P Q R S. All four pins are in a straight line. Four pins are in a straight line. Straight line. Four pins are in a straight line. Now gas slab is present on the board. The gas slab is removed. Now gas slab is removed. Removed. Now gas slab is glass slab is removed from the board. Now, so what we have to do, this is two dotted lines, two double lines. Now we want to remove glass slab is removed from the board. Now I'm taking the scale. I'm taking the scale. I'm taking the scale and drawing to the normal line. So first I join these two dotted lines. Remove the two pins. Join the dotted lines. Two lines and joining. This is one more pin. P Q R S. All are in the stand. So next, draw the normal line. Here, this is a stand. This is a normal. This is a normal line. Normal. This is a normal line. Now you can see what will happen in this situation. You will see this is the angle of phi. So we call this is the angle of phi is 30 degrees. This is now you will see this is a two pins. I'm trying to do these lines. This is a lines. This is we call emergent. We call emergent line. This is we call normal line. Normal line. So here angle between N and E means this is the angle of emergent. Angle of emergent ray. Angle of emergent. Now you will see. Now I'm going to join these lines. I'm going to join this. This is we call refractoring. This is a refractoring. Here angle of we call this is the angle of refractoring. This point angle of refractoring. Angle of refractoring. Angle of refractoring. Now we will see. Now, so this is a lines. You see the lines and you see now glass slab is removed. This is right. Now glass slab is placed. Glass slab is placed on the board. Placed on the board. Placed on the board. Now glass slab is present here means this is a beam of light. This is a beam of light is traveling towards the other medium. Traveling towards medium. And this bending inside, bending like this. This is a bending. This is a light again. It travels from. It is moving to this direction. Now you can see this is a radar medium. This is a denser medium. Again, this is a radar medium. Light travels from radar to denser means this is an incident ray. This is a refractory. Refractory is bending towards a normal line. Light travels from radar to denser means refractory bends towards a normal. Now again, light travels from denser medium to radar medium means this is actual direction of incident. This is actual direction. This is actual direction of incident. But light travels from denser medium to radar medium means this is incident ray. It travels from denser medium to radar means this is emergent ray. Emergent ray. Light which emergence out. This is another medium. This is the emergent ray is away from the normal. Now, so glass slab is present means glass slab is present here means this way is bending this direction. Now it is moving. Glass slab is removed. Glass slab is removed. Removed means removed. Glass slab is removed. This is a beam of light. This beam of light is ghost light. Ghost light. Now, what I'm explaining? Glass slab is removed from the board. Removed from the board. Removed from the from the board. Removed from the board. Glass slab is removed means this is a beam of light. Beam of light is ghost light. This is ghost light. This is actual direction of incident ray. This is actual direction of incident ray. Actual direction of incident. Now glass slab is placed. Now glass slab is placed on the board. Glass slab is placed on the board. On the board. Glass slab is placed on the board means this beam of light is traveling towards another medium. It is bending in this direction, and it goes to this direction. It goes this direction. So glass slab, there is no glass slab means this is ghost light. Glass slab is present means it is shifting this direction. Glass slab remove means this is shifting this direction. Glass slab base means this way is shifting this direction. Shifting this direction because that is a lateral shift. Lateral shift. What is the meaning of lateral shift? Means you see this is the actual direction of incident ray. This is an emergent ray. Distance between or distance between emergent ray and actual direction of actual direction of actual direction of incident ray. Distance between emergent ray actual direction of incident ray is called as lateral shift. Lateral shift. This is we call lateral shift. This is we call lateral shift. Lateral shift. We are calling this a lateral shift. Distance between the two parallel lines. Distance between the two parallel lines is called as lateral shift. Lateral shift. So we take with the help of protractor and scales, we are measuring angles. This is 20 degrees. This is angle of E is exactly we are getting 30 degrees. This is a lateral shift is 1.3. This distance measures by the scale. Distance measures by the scale. This is how much distance this one is 1.5 centimeters. This is the angle of E is 30 degrees. Angle of E is 30 and the angle of E also 30. So what is the reason? Angle of E is equal to angle of R. What is the reason? Means AB is equal to the DC lines. This AB line is parallel to the DC lines. DC line. AB line is parallel to the DC line. That's why angle of I is equal to angle of E. Angle of I is equal to angle of E. Both of parallel lines means the angle of incident ray is equal to the angle of emergent ray. Both are equal. This is we are understanding the lateral shift. Lateral shift. This is lab activity 2. Lab activity 2. Lab activity 2. One second, I'm going to explain this concept. Now, it will say lab activity 2. Refraction of light at a plane surface. Plane surface. Now, we are in the refraction of the light at plane surfaces. I'm going to explain lab activity 2. Lab activity 2. 1 second, I'm going to explain lab activity 2. Now, so first of all, what we need. So first, what is our aim? Our aim is so aim. Aim is the our aim. What is our aim? Understanding what we understanding lateral shift, lateral shift shift y glass slab glass slab. Understanding lateral shift by using glass slab by using glass slab by using glass slab glass slab glass slab. Now, what is the meaning of lateral shift? Lateral shift. Lateral shift means this is a line. This is a line. This emergent ray extend backward direction. This is a backward direction. We can extend. You will see this is the actual direction of incident ray. This is a emergent ray. This is the actual direction of emergent ray. You see two lines are parallel to each other. Parallel to each other. Parallel to each other. And this is a distance between the two parallel lines. This is a distance between two parallel lines. Distance between two parallel lines. Distance between the two parallel lines is called as lateral shift. Lateral shift. Distance between emergent ray actual direction of incident ray is called as lateral shift. Lateral shift. Lateral shift. This is lateral shift. We are going to show that this one. So how we are going to show this one means with the help of practical experience, practical activity. So we are going to explain the activity. Understanding lateral shift by using the glass slab. So now you would say this is a glass slab. Now, so you see the glass. Now what we have to do here. So first of all, our aim is understanding lateral shift by using glass slab. Now next material. We require material required. Material required. What type of material required? What type of material we need? We need material is first of all glass slab. So first is glass slab. Next to protector. Next to scale, pencil, eraser, pins, white paper, drawing board. These all things we need. All things we need. Next, procedure. Procedure means what we have to do here. That's all I'm going to explain. What we have to do. What we are doing here. That only explain step by step. Step by step. So first point is so we select the drawing board. We arrange the drawing board. Next, so we are taking the white paper. The white paper keeps on the board. White paper attaches to the board with the help of the pins. The paper is should be tied with the help of the pins, and pin is attached to the white paper, and the pin attaches to the white paper and drawing board. The paper, white paper is very tight. Now next, what we have to do next, glass slab. Glass slab is plain glass slab places on middle of the paper. Now next, you take in your hand pencil, and we have to draw outlines of the glass slab. Now just your finger keeps on top surface of the glass slab. Glass slab should not skid on the paper. Now your finger keeps on the glass slab. Next, another finger with a pencil and we draw the outlines of the glass slab. Then, so we remove the glass slab from the board. We remove the glass slab from the board. Now, next, you take the you find the this what is A, this what is B, this is C, this is A. So we should indicate the points. Okay. Next, you take the protector. The protector, this is a AB line, and the protector having the one line, horizontal line. The protector of horizontal line, AB line should be coincide. The protector keeps on AB line. Protector having the one line. The line matches to the AB line. AB line. So you put the one dot. You put the one dot and remove the protector and with the help of the scale. So we draw the straight line joins the two dotted lines. This straight line is perpendicular to the AB line. This straight line is called as the normal line. Normal line. Once again, so we draw the normal line. Again, the protector should place on AB line. The protector having the horizontal line, the line matches AB line. So we keep the protector here. Again, so we want the incentive. 10 degrees, 20 degrees, 30 degrees. Right? So remove the protector. Remove the protector. Next, this dotted line is straight line joins the two dotted lines. That indicates the instant ray. Instant ray. Now, so you take the glass slab. So glass slab is placed on the board. Glass slab is placed on the board. You take the two pins, P and two pins. Two pins or pin is insert on the board. This is another pin. This pin also insert on this line, on this tight line. Two pins are in a same height. We should maintain two pins are same height. The same height, two pins are the same height. Your glass slab is present. Now, next, what we have to do means our eye keeps here. Our eye keep here. Our eye keep here this side. Our eye keep here. Glass slab is present. I'm seeing to the two pins. I'm seeing to the two pins. Two pins are in a straight line. I'm seeing to the two pins through the glass slab. Through the glass slab. This side also, I have to take the two pins. We have to attach the two pins in a straight line. All P, Q, R, S. We have to four pins. Four pins are in the straight line. In this R, S pins also should keep in a straight line. Now finally, P, Q, R, S pins attached in a straight line. When we have seen to the P, Q pins, when we have seen to the P, Q, R, S pins, we have seen to the P, Q, R, S pins are in a straight line. When we have seen to the glass slab, when we have seen to the glass slab, then glass slab is removed and we have to draw it. And these two dotted lines. And remove the P or S pins. We have the two dotted lines. Now, so straight line joins the two dotted lines. Straight line joins the two dotted lines. Now, next we have to draw the normal line. So what will happen next? And remove this one and draw the all lines all appearing. This is instant ray. This is an instant ray. This is an angle of incident. This is a refractor ray. This is an emergent ray. This is an angle of emergent ray. Angle of emergent. Beam of light. This is a beam of light is traveling towards another medium. It is bending. This is a refractor is bending towards a normal. Again, light travels from denser medium to rarer medium. Again, refractor ray, emergent ray moves away from the normal. But it's a basic point. You know, light travels from rarer to denser means a refractor means towards the normal. Again, light travels from denser medium to rarer medium means refractor moves away from the normal. This is the actual direction of incident ray. This is an emergent ray. Glass slab is present means the ray is light travels from rarer to denser means refractor means towards the normal. And here glass slab is present means light travels from denser medium to rarer medium. Refractor is bending away from the normal. Now glass slab is removed. Light is passing. Light passing, light goes straight. Light goes straight. When glass slab is offset, glass slab is removed from the display space. The light goes straight. Light goes straight. Suppose glass slab is present, light goes this direction and bending this direction away from this direction. Now glass slab is removed. This light goes straight. Glass slab is present. This is shifting this direction. Glass slab is removed. This is goes straight. Glass slab is placing. This is shifting this direction. We call this is a lateral shift. Distance between two parallel lines. This is a parallel line. Two parallel lines. This is actual direction of incident ray. This is a convergence. Two lines are there. Two lines are there. Distance between two parallels is called as lateral shift. Lateral shift. So distance between emergent ray actual direction of incident ray is called as lateral shift. Lateral shift. Angle of E is equal to 30 degrees. Angle of E also 30 degrees. So what is the reason two angles are equal? Means AB line is equal to the DC line. AB line is equal to the DC line. Both are equal. Both are equal. That's why angle of I is equal to angle of E. Angle of E. Now you will see angle of I is equal to 30. Angle of E is equal to 30 degrees. Angle of R is equal to 20 degrees. Now this is the distance is equal to 1.3 centimeters. This is a distance. This is a distance measures by the scale. Scale. What is the value of lateral shift? 1.3 centimeters. This is a practical values. That is a practical values. This is a lab activity 2. So we have the two lab activities here. So one is lab activity 1. Light travels from radar medium to denser medium. We are showing relation between angle of I, angle of R, angle of I, angle of R. Next relation between another one is this is a lab activity 2. In this lab activity, I am studying the lateral shift by using the glass lab. This is our activity. Now, you will see, suppose, for example, in this variation, suppose you are doing to another experiment. Suppose this is a 40 degrees. This is a 40 degrees. You are getting practical value here 40 degrees. You are getting some value here. Here you are getting some value. It will be changes. It will be changes. Now this is a 20 degrees. This is a 20. You are getting here also 20. What is the reason? AB line is parallel to the DC line. Now you are getting some value. Here you are getting some value. You are getting some value. Now this is a 40 degrees. Now you are getting here 40 degrees. Some value you are getting here. Some value. Lateral shift you are getting some value. So this is we are doing the practical way. Okay. So this is a lab activity 2. This form. Next activity 4. Activity 4. So what is the activity 4 means? Basic point. So light travels from denser medium to light travels from denser medium to radar medium. Means this is interface line. This is what we call interface line. This line can be divided into this is a denser medium. This is a radar medium. Now we will take so it is radar medium. Radar medium. Downside is denser medium. Now this is beam of normal line. This is a beam of light is traveling towards another medium. Now this is the actual direction of incident ray. Light travels from radar to sensor means it is bending away from. This is a before This is angle of y. This is the angle of y. Angle of y deviation is equal to angle of y minus angle of y. This is the basic one. Activity 4 is this is concept. Activity 4 is this is a concept. Light travels from tensor beam to radar medium. This is light is travels from radar to tensor means refractory moves affecting the normal. This is a deviation. Not only we are showing, we are going to show that this is this is I'm going to show this I mean this deviation. Not only we are showing now in practical way. Now today class is over. Tomorrow I will explain next.